All right, this is continuing section 7.3. We're still working on multiplying binomials. So here, what we first want to recognize is that we have a binomial squared. So that means we're going to take our first term, which is 2x, and we're going to square it. And then to that, we're going to add 2 times the first term, which is 2x, times the second term, plus the second term squared. And so now we see 2 squared is 4x squared, plus 2 times 2, which is 4, and 4 times 3, which is 12x, and then plus 3 squared, which is 9. Remember, always simplifying. You don't just leave it with pattern. Our next problem, we see that we have a binomial times a binomial where we have the same two terms, but we have one's a sum, one's a difference. That's multiplying conjugates. When we multiply conjugates, we take our first term. So we see that our first term is a 3a, so we're going to take our first term and we're going to square it. And then we're going to subtract, and we're going to subtract our second term, which we see is a 1/4, and it is squared. So we have 3a quantity squared, so that's square the 3, 9, square the a, 9a squared, minus 1/4 squared. 1 squared is 1, 4 squared is 16. So our answer is 9a squared minus 16. Our next one, we have a binomial squared. So this is r squared squared plus 2 times r squared times 1/2 s, and then finally plus, and then quantity 1/2 s quantity squared. So r squared squared, that means we multiply the exponents. Remember, that's the power rule for a power raised to a power. Or excuse me, not a product rule, that's the power rule for a power raised to a power. So we have 2 times 2, which is 4th power, and then plus, and 2 times 1/2, which is 1, and so we have 1r squared s, and then plus 1/2 squared, 1 squared is 1, over 2 squared, which is 4, and then we have s squared. And so there's our final answer on that one. And yeah, it has a fraction in it, but we don't want to let it bother us. Okay, now moving on to our second example. Our second example, we're going to be finding some higher powers of exponents. So with our higher powers of exponents, we have to remember that this is expanded out. One of the mistakes that students will usually make on this is they'll forget their expansion of exponent. Remember, the exponent says the base, oops, those are 5s, repeatedly multiplied by itself. So we have y plus 5 times y plus 5 times y plus 5. And what we want to recognize on this is that y plus 5 times y plus 5 is y plus 5 squared. So what I'm going to do is I'm going to square out that, right? Take the first term and square it. Add to it the 2 terms multiplied times 2, so 2 times 5, which is 10, times y, and then plus 5 squared, which is 25, and we're going to multiply that by y plus 5. So I'm going to apply my topics from the last section, so I'm going to do long multiplication there. So I'm doing polynomial multiplication. So 5 times 5, 25, which is 125, plus 5 times 10, which is 50, y, and then plus 5 times y squared, which gives me 5y squared, and then moving over to the first degree term, y times 25, which is 25y, plus, and then y times 10y, which is going to give me 10y squared, and then plus y times y squared, which is y cubed. And now we can add y cubed plus 5 and 10 makes 15, and those are y squared terms, plus 50 and 25, which makes 75y, and then plus 125. And now we can see our final answer. So that applies what we had learned in the previous section, as well as our binomial squared. We'll save the next 2 examples for the next video.